Yeah, thank you for that introduction. As you noted, my name's Stuart. I'm the Chief Digital Transformation Officer for SAF-CN at the Department of the Air Force. I'll start by quickly describing what our organization does. I'm going to jump into kind of the way we're thinking about problems and the way we're solving them. And then I'll end by noting kind of the way we're applying this to responsible AI in the Air Force. So within my organization, which is SAF-CN, we have the Chief Information Officer, we have a head of enterprise IT, we have also a Chief Information Security Officer, a Chief User Experience Officer, and we primarily focus on IT policy and networks, and enabling the Air Force to build a warfighting network. And of course, today is about artificial intelligence. So I'm going to talk about how we're thinking about the data challenges of AI and the ability to leverage them for specific use cases. And I'm going to jump into that now. So from my experience, I'm a former software developer. I was at Microsoft where I developed software, and I worked extensively with telemetry data. And these are some observations I've taken from industry that I'm seeking to apply into the Air Force. And so this presentation is called Telemetry: How Big Tech Wins, and in lowercase, some possible lessons for DoD. And so, as you know, in the Air Force, General Brown has put out this requirement that we accelerate, change, or lose. And there's many scientists on the line, which is good because I get blank stares sometimes when I show this. But as you know, acceleration is the second derivative of position, and velocity is the first derivative based on time. And so, the point I'm trying to get here is that in order to actually accelerate change, we need to be able to measure and know where we're at. We need location to measure acceleration as well as velocity. And so, the thought is maybe we should be measuring where we're at in order to actually effectuate this. And so, like, what is telemetry? Because I didn't know that when I first started as a software developer at Microsoft. It's the process of recording and transmitting the readings of an instrument, according to Google. I think Wikipedia's definition is much better. It refers to the automatic transmission to receiving equipment for the purposes of monitoring. It starts to talk about what its purpose is. And my working definition and experience at Microsoft was it's the automatic collection and aggregation of remote data to improve decision making. And that decision making could be made by a machine or by a human being, right? But in order to make sound decisions, you need kind of like an automation of visibility is what I call this, in which you automatically are collecting data about the state of your systems. One second here. So what are the benefits of like telemetry, and why are we doing this? So we have kind of three things we're thinking about. The first is we want to measure the health and the return on investment of our systems. The second is we want to be able to find dependencies. Once you have those health measures, you can actually intentionally break your systems to find points of failure by degrading those systems in some way. And you could, of course, automatically do that. And then the third is the advanced analytics and automation via algorithms that we're talking about here today. And my assertion is that every big tech company in the world undergirds on telemetry. It's not something a lot of people talk about, but that's been my experience. And I'm going to run through as many examples as I can with the time I have. So at Microsoft, where I worked on health of systems. And basically what you can imagine is like you have all these Windows operating system devices as well as third-party software devices. Your phone, HoloLens, Xbox, Windows computers, Windows servers, many things you may not at first have thought of when you think of the Windows operating system. And it's over 1 billion plus devices. And basically, we were interested in understanding the reliability, the performance and power usage and user experience of those devices for the purposes of making a profit. And what's interesting about this scenario is that in each device, they're all very different devices in some respect, but we undergirded them with the same platform, and we were collecting all of this telemetry data, like, for example, crash logs, or performance tracing information or power tracing information that said, this is the experience on this device at this moment. And that was really important in order to improve and track these metrics and know, number one, when to release new software and when it was reliable and performant and whatnot. And number two, to be able to track down problems within that system. And so, and then third, I guess we were actually prototyping new devices and new software using this and testing it to know when it was ready to be released. That's my first example. My second example is from Google. And as you probably know, Google started out with the PageRank algorithm and ultimately produced a ranking for web searching. And what's really interesting about what happened here was that Google was collecting all of this data. They were, of course, using supervised learning to improve the ranking, the unsupervised ranking system. And ultimately, what's really interesting is they created this Google search, this ability to Google search trends is what it's called. And what came out of that, one example that came out of that that's really interesting is the detecting of influenza epidemics using search engine query data. They were able to predict the spread of flu on an order of 3 or 4 weeks faster than the CDC. And the reason they were able to do that is because people search for their symptoms before they go to the doctor. So one of the interesting outcomes of telemetry collection is that you can start to learn things about your systems and your users that you wouldn't have even expected or designed for. I don't think anybody at Google designed Google search and said, we're going to predict the spread of flu faster than the CDC. But that's exactly what happened. And this is illustrated in this book, Everybody Lies. And this is an example of crowdsourced learning and understanding that comes from the collection of data and telemetry. Third example is Facebook. I'll make this quick because I think I'm running out of time. But basically, Facebook, during Hurricane Sandy, looked at their data centers and said, what would happen if our data centers went down? And the conclusion they came back with was we would lose service or services across the East Coast for Facebook. And they were lucky their data centers didn't go down, but they ended up creating a group that called Project Storm that ultimately went and instrumented their systems in order to make sense of their bottlenecks and where those dependencies existed. And then they actually intentionally brought down their data centers. They actually pulled the network cables out. And they did that, and they still do that, and multiple data centers to increase reliability. And so the benefit is when you pull those network cores out, the key thing is to be able to make sense of what's happening, and the way you do that is with instrumentation. This example with Tesla, I think, is the most obvious, where they're collecting all sorts of information directly off the car when it engages in autopilot, when it disengages, and in order to produce the AI assistance and automation that many of us are seeking for the DoD. The fifth example, this is what I call Amazon's kill chain, actually. If you look here, and it's really incredible, they're providing their telemetry information directly to users from the shipping soon to the delivered, and the way that Amazon has been able to produce such incredible revenues, be the primary, provider of basically web purchases and shipping for them, is because they have closed that kill chain considerably in comparison to their rivals. The way they've done that, in industry, we call these mean time to metrics. And so basically, as they close from shipping, from the time you click buy now or buy to the time it's delivered is the area that they're interested in closing, right? And so by being able to collect this telemetry data, you can start to find where are your bottlenecks and how are changes to your system improving those bottlenecks. Okay, the last example I'm going to go over is with Netflix. So many of you might be familiar with this problem, the challenge of basically movie recommendations. So you've got a sparse matrix of you've got users on the rows and movies on the columns, and basically it'd be very hard to watch every movie on Netflix. I think you got to know that there's enough time in your lifetime to do so. So it's sparse. Most people haven't watched most movies. And the challenge that they're trying to solve for with collaborative filtering is how do we leverage the users who are like you, who've watched similar things to you and enjoyed them, to recommend the best content to you, right? How do we find groups that are like you? And so this is effectively how they've produced their recommendation engine for movies, which has been crucial to the discovery of content and has enabled them. So these are kind of the approaches we're thinking about at SAFCN to understand and inform our investments into new services and capability, and ultimately, a large portion of this is undergirded with AI. So the last thing I'm going to talk about real quick is that it looks quite probable we will be one of the leads on the Responsible AI initiative that was led by the JIG and signed out by the DepSecDef and SAFCN and SAFCO. CEO is the Chief Data Officer office. Looks like we'll be leading or playing a significant role in that effort, and are excited to kind of apply some of these techniques and these thoughts around automation of visibility in order to ensure responsible AI. Hopefully this was an interesting presentation, and happy to take questions later. Thank you.